Alright, so that's the weight. Let's now, as I drop this into the water, the weight's going to change. Let's say as I lower this weight into the water, this weight, by the way, is matched to this cup. There's a cup here that has it on top of it that has the same weight as this. So, in fact, it's the same volume, right? So now, if I lower this into the water, we say that the water, what's going to happen is that this scale is going to, if there's a buoyant force coming up, it's going to be a force acting on this pushing it up, the weight's going to be less. So the difference between what it reads now and after I lower it in is going to be the buoyant force. So let's just see what that is before we go any further. All right, so we start at 12 and a half. Let me just crank it up, it gets less. Because the buoyant force is proportional, right, to how much volume I'm displacing, so it keeps getting more and more as I displace more and more water. So let's get it all covered up. So we started at 13 and a half, so it goes to 9, about 9. So that's like 3.5 newtons, right? So the buoyant force is about 3.5 newtons. Now, we claim that if that's the force, that's equal to the weight of the water that was displaced. And the weight of the water that's displaced is the volume in this can. So we set it up that way, right? Now, if I take the water here and I fill up this can, that's going to match the buoyant force. So therefore, it should cancel it out, and then this should go back to 13, right? So let's just pour it in here. Almost. All right, so this should match that. So that says then that the force that this pushed up on it is equal to the force by the weight of the water in the can. It's the same amount that was displaced.